Hello, hello. Hi guys. Am I live? A very warm welcome. Welcome to Vedantu JEE English channel. And by the way, before I start with the session, a very happy new year. And I hope that this year, your goals, your ambitions, may you achieve your dream IIT college and come back here and let us know that yes, mom, we did it. Yes, I will be waiting definitely to see your chats. Everybody, do come back and let us know. And now, as I always say, this I'm not going to change this year. That is Antariki Namaskaram, Elargu Swagatam, and a very warm welcome to your own Vedantu J English channel. This is me, your master teacher, Nabamita Ma'am, and today we are going to solve some of the most important questions from these two chapters. So basically, in one session, we will be covering redox as well as electrochemistry, and we have seen that in the past from these two chapters together, right, there are also at times when they merge these two chapters, and you will be able to see at least 2 to 3 questions from these chapters. And sometimes what they do is they also merge the concepts with some other chapter, right? Like for example, redox can be combined with your DNF block and they can ask you a question. So in that way you will be able to achieve 12 marks if you actually sit and study properly and solve the questions with me. So everybody, are you all ready, guys? Are you all ready, everybody? I have redox titration questions, bacha. And Deepika, I believe that I have already taught you the chapter once, but if you think that you are not done, don't worry about it. I think in the flash series I will be able to take you through the chapter again. All right? Yes. We have questions related to redox titration. Please see that these are all power PYQs. Okay, so we are not dealing with the concepts today. We are not dealing with the concepts today. We are doing previous year questions, but choose. And I have taken the redox chapter, the whole chapter. I took you through it, right? Don't you remember? I've taken you through it. It's there in the channel. It's there in the channel. If you have missed out on some concept, then please go and have a look at it, okay? Srinivas, hello, bacha. I do not understand Telugu. If you're writing something there, I'm so sorry. I can only understand English, Hindi. Yeah. All right, everybody. Shall we start, guys? Shall we start, everybody? Yes. Are we all ready for the new year and new Josh? What do you all say? Yes. Can we believe in PYQ? No, I am just passing time. What do you think? Huh? Do you hear my voice? I'm not well. Why do you think that I'm taking this session? Because it is utmost importance. Yes, from the PYQ, you can actually understand what kind of questions will come. So yeah, it is important. You did not read 11th. Why would you do this? I'm not audible? Am I really not audible, guys? Am I not audible? Are you all able to hear me? Happy New Year, bacha. Happy New Year, everybody. Quickly go and call up your friends and let us start. So, chalo. By the way, before I start with the session, let me also show you that today you must have seen that semiconductors and logic devices that was taken by Shreya sir. Right now at 9 p.m. I'm taking this session, that is redox and electrochemistry. Tomorrow you have vector algebra by Nabamita Ma'am, and you have reaction mechanisms, haloalkanes by Pahul sir. Yes, day after tomorrow, that is on Thursday at 6 p.m. I will be taking thermodynamics flash series, one of the very important, utmost important chapter. It is a high weighted chapter, so be there, be there, be there. All right. Yes. Aapki IIT se ho? Yes, I am from IIT Guwahati. Okay. All right, bachos. And then as you can see, right, the other schedules are also there. Friday you have alcohol, phenols and ethers and vector and 3D geometry quiz. Saturday, as usual, you will have marathon. All right, everybody. Yes. So let us go and start with the first question. And the first question, everybody, this is a JEE Main 2023 question. And the question is, read it, everybody, read it. I'm going to be a little soft spoken today because, my voice is not going to support me otherwise. So yeah. At 298 Kelvin, a 1 liter solution containing 10 millimole of Cr2O7 minus and 100 millimole of Cr plus 3. It shows a pH of 3.0. What is given to you? What is given to you is that Cr2O7 minus goes to Cr3 plus, right? E naught value is given to you, that is 1.330 volt, and you are also given 2.303 RT divided by F, that is Faraday's constant, yes, is equal to 0.059. Now they are asking you that the potential for the half cell reaction is X multiplied with 10 to the power minus 3 volt. What is the value of X? What is the value of X? That is what we have to calculate. So shall we start then? Let us start, everybody. Now first of all, we are going to do what? We are going to write the reaction. What is the reaction? The reaction here, my dear students, is Cr2O7 2 minus, right? Yes, and as the, see in the question it is written here, Cr2O7 2 minus goes to Cr3 plus. It gets converted to Cr3 plus. So chalo, let us write that down, Cr3 plus. Acha, now tell me something. Here you see that Cr2O7, right? Here this one is in +6 oxidation state chromium. Yes, you all know how to calculate the oxidation state, right? I have taught you how to calculate oxidation state in coordination number. You all know that, yeah. So Cr2O7 2 minus, Cr is in +6 oxidation state. It gets converted to +3 oxidation state. Okay. Now if I have to balance it, I will write here 2 Cr3 plus. Am I right, everybody? Yes. Cr2O7, here it will be 2 Cr3 plus. Okay. Acha. Now that means that here there is a difference of 3 electrons, but since there are 2 moles, so that means the difference is now 6 electron. Am I right? Yes. 6 electron, 6 electrons plus I also see that, do you remember how to balance the chemical equation? We know about it, how to balance the chemical equation. So right now what am I going to do? I will add here 14H plus. That means here this side I will be adding 7H2O. Make sense, everybody? Yes, the reaction is balanced now. Okay, all right. All right, everybody. So now from here I can understand that what do I have? I have the formula E cell is equal to, everybody, E cell is equal to E naught cell minus, if you remember, 0.059 divided by N. This is an important formula, everybody. Please have a look, everyone. Do not just leave the class because you think that, oh, I can't understand, it's so boring. This type of questions do come, okay? Srinivas, what are you doing, bacha? Why are you spamming so much? Huh? Huh? Why are you spamming so much? You haven't studied, and this is the fact that you have to pay attention right now, right? Why are you spamming constantly? Don't spam. Be in the class and study, you know, what I'm teaching. Otherwise, you will not be able to understand anything. Please study. Okay? Yeah. Do you remember this? Do you guys remember this formula? We have studied this in electrochemistry chapter. Now, you can clearly see that E naught value, E naught cell value is given to you, see, 1.330 volt, that is given to you, right? So, what do we have to do? We have to now substitute the values. Shall we do that? Let us do that, everybody. Let us have a look at it. So, what are we going to do? We are going to substitute the value here. So, 1.330 volt minus 0.059 divided by N. What is this N? Do you see here? 6 electrons are required, isn't it? 6 electrons are required for Cr2O7, that is in +6 oxidation state, to get converted to 3 plus oxidation state. Yes, 6 electrons are required. So what do we have to do? Instead of N, now we are going to put here 6. Okay, all right. Now, see what I'm doing? Log of product. What is product? Product may, everybody have a look, guys. Product may, what you have? Product may, right here you have Cr3 plus, right? You have Cr3 plus. And in the reactant side, you have Cr2O7 and you have this 14H plus. So we are going to write that. Chalo, let us do that. So here what are we going to do? We are going to write Cr3 plus here divided by reactant side. So Cr2O7, yes, O7, 2 minus, and here what are we going to do? H plus to the power coefficient, stoichiometric coefficient, yes, H plus raised to the power stoichiometric coefficient, everybody. So H plus to the power 14. Chalo, now we are going to solve it furthermore. Yes, let us solve it furthermore. Now what is given to us? Remember, in the question it is also given to you that pH is equal to 3.0. Do you see here? pH is equal to 3.0. That is also given to you. That means, everybody, now have a look. Because pH is given to you as 3, That means, don't we know that H plus is definitely is equal to 10 to the power minus 3. Am I right, everybody? Am I right, everybody? Yes, guys? Please tell me yes or no. Hello. Instead of just spamming, say yes or no. What happened to the Josh, guys? Huh? What happened? New Year's have come, so we have like forgotten how to chat with the teacher, how to interact in the class. Guys, are you here or not? CR plus 3 to the power 2. Yeah. Yes. Very good. Good. That means somebody is listening. Thank you, Ayush. Yes. CR raised to the power, CR plus 3 raised to the power 2, because that also has a stoichiometric coefficient of 2. Very good. Yes. Now in the question, pH is equal to 3 given. So that means H plus is equal to 10 to the power minus 3. Right. Great. What else is given to you? What else is given to you? Do you remember there is something written as 10 millimole of Cr2O7 and 100 millimole of Cr3 plus? That means, what does that mean? Chalo, let's see what does that mean. So it means that 10 millimole of Cr2O7 2 minus is basically equal to, how can I write 10 millimole, bacha? If it is 10 millimole, millimole means 10 into 10 to the power minus 3. Am I right? 10 into 10 to the power minus 3. Yes. That means that this is equal to 10 to the power minus 2 mole per liter. Am I right? Yes. This is what it means. Correct? This is what it means, isn't it? Very good. Very good, everybody. You guys are understanding? Well done. Okay. Now, what happens is, what is given to you is 100 millimole of Cr plus 3. Yes, Cr plus 3. That means, what do I get to do? I have to write 100 multiplied with 10 to the power minus 3. That means if I solve it, I will be getting 10 to the power minus 1 mole per liter. Am I right, guys? Am I right here? Yes. I am right. Correct. Very good. Yes. Will you teach thermo and redox titration? Bachu, yes, thermo I'll be teaching on Wednesday, and redox titration, yes, I will teach you. Okay. Redox titrations, I will teach you. All right, bachus? Yes, I will teach you. Okay. Chalo, moving on. So 100 millimole of Cr plus 3 is equal to 100 into 10 to the power minus 3 is equal to 10 to the power minus 1 mole per liter. Right. We get it. Okay. Now, coming back to this equation that we have solved, everybody, have a look, guys. This equation that we have solved, everybody. Yes, from here, what do we have? 1.330 minus, what do we have? 0.059 divided by 6. Yes, log of 10 to the power, see, Cr3 plus to the power 2, right? To the power 2. So 10 to the power minus 1 into 10 to the power minus 1, right? Divided by Cr2O7 2 minus, concentration of Cr2O7 2 minus, so 10 to the power minus 2, correct? Yes, multiplied with 10 to the power minus 3 to the power 14, everybody. Yes, to the power 13, everyone, right? Guys, are you all with me? I still cannot see your chats. Where are you guys? Yes, finally, huh? I think there is a sort of yes. Yes, all right. Okay, great. Okay. All right. Now, if we solve this cancel, this cancel, this cancel. Am I right? Okay. All right. So, what do we get? We get 1 point. Okay. Moving this up a little bit. 1.330. Yes. Or 330, whatever it is. Minus 0.059 divided by 6. Yes. Log. What will it be? 1 by 10 to the power minus 42, because minus 3 and 14. Minus 3 and 14, right? So it will be 10 to the power minus 42. Yeah, great. Okay. Now, calculate this, bachos. Now, can you all calculate? I think you can calculate this and figure out the answer. But anyway, let me simplify this a little bit more. Let me simplify this a little bit more. 1.330 minus 0.059 divided by 6 log. So log 1 by 10 to the power minus 42 can be written as log 10 to the power 42. Yes. This is equal to 1.330 minus 0.059 divided by 6 multiplied with 42, because this log also has base 10, right? This log also has base 10, so base 10 cancel, base 10 and 10 get cancelled, so it will be 42. Now if you simplify this, I think you will be getting E naught, no, I think you'll be getting E cell value is equal to, guys, calculate and tell me what is E cell value. What is the value of E cell, everybody? Chalo, let's calculate this. The E cell value comes up to 0.917. That means that we can write this as, everybody have a look, we can write this as 917 into 10 to the power minus 3. So what were we asked? You were asked x value, see, x multiplied with 10 to the power minus 3. So your answer here is 917. That is your answer. Please check, did you all get this answer, everybody? Yes? Are you all getting this answer, guys? 917? Very good. Hashtag EPBT also I can see. Yay! I can also see hashtag EPBT. Yes. What do you mean by no clarity? Kishore Kanan, what is E cell, ma'am? Bro, guys. Bachus, I really hope that your exam is in the next 20 days. Next 20 days, everybody. I really hope that you guys are not the class 12 standard kids who are going to appear for the JEE exam. Are you? Are you? Kishore Kanan and Naufal, Muhammad Naufal, are you guys going to appear for the exam? If you are, I'm very sorry. Then that's the most basic thing that you're supposed to know. Right now, if you're asking me, what is E cell? I am scared for your JEE now. Okay, so everybody, EPBT guys, let's check the answer. Yay, we're right. 917. Give me a virtual high five, everybody. Great. Okay, listen to me. Do you see? I have cold, cough, everything. I'm personally not very motivated right now to teach you. I need your chat to be able to get motivated. So if you are not telling me, if you're not interacting with me, it is going to be very difficult for me. And I might just die because I am like out of breathing. All right, so interact with me, otherwise I'm not at all motivated right now, and I might just sleep off, fall off right away, unconscious, drop dead, whatever. So yeah, need your interaction. Chalo guys, moving on to the next question then. Yeah, the next question, everybody, is consider the cell. Okay, here you consider the cell. Your cell is PT. Yes, PTS goes to H2S at 1 atmospheric pressure. Then here you have H plus aqueous. Then H plus concentration is equal to 1. This is the salt bridge. Then Fe3 plus aqueous to Fe2 plus aqueous and PTS. So do you understand that one side you have taken standard hydrogen electrode. One side, what have you taken? On the one side you have taken She, that is standard hydrogen electrode potential. On the other side you have the ion, right? So from here, what do we understand? From here, chalo, let us write down what are the things that are given to us. Yes, let us write down what are the things that are given to us. Now, first of all, what is given to you? You are given E naught is equal to E naught of Fe3 plus to Fe2 plus. Yes, E naught Fe3 plus Fe2 plus is equal to 0.771 volt. That is given to you. Right, everyone? Yes, that is given to you. Great. And what is given to you? And you are also given that E naught H plus half H2 is equal to 0 volt. That is obvious. That is why we use it as a standard hydrogen electrode potential, right? So now coming back to the concept, now we have to write down the whole equation, right? Yes, now we have to write down the whole equation. Yes, everybody? Yes, shall we? Chalo. Now our equation is going to look like, everyone have a look guys, have a look. Please pay attention. This can be a little confusing. You do not pay attention, you're going to miss out on it, okay? So you will have half H2, see, half H2, right? Plus, okay? Fe3 plus, which is in the aqueous form, yes, will form here H plus aqueous plus what? Fe2 plus, yes, Fe2 plus aqueous. Great. Now once again, what formula do we use? We have one formula that we are going to use the most, and that is, everybody, your E cell is equal to your E naught minus 0.059 divided by N. Here, do you see Fe3 plus to Fe2 plus? So, how many electrons ka len den? How many electrons are how many electrons are going for this give and take relationship? 1. Fe3 plus to Fe2 plus. So, 1 electron, right? So, instead of N, can I directly write here 1? Will you all remember? Will you all remember if I write it down like this? Yes. Okay. Alright. Now what do we have? Same log of product divided by reactant. So product is Fe2 plus. Do we have any stoichiometric coefficient? None. Divided by Fe3 plus. That's it. Okay. Now further, let's solve it. What is given to you? E cell. See, your E cell is given to you, isn't it? See, if the potential of the cell is 0.712 volt, see, 712 volt, that is given to you. That means that you are going to write it as 0.712 is equal to, now, E naught cell is also given, see, E naught 0.771 volt given to you. So, what are you going to do now? You're going to write here 0.771 minus 0 minus 0.059 divided by 1, and then what? Log, yes, same to same, Fe2 plus divided by Fe3 plus. That's it. Okay. Now we just have to solve it. Solve it, everybody. What will you get? All you have to do is bring this side, log Fe2 plus divided by Fe3 plus is equal to, what do we have? 0.771 minus 0 will be 0.771. 0.771 minus, this will go that side, so minus 0.712 divided by, this is 0.059, so I can just write it as 0.059. Okay, now solve this. How much do you get? Solve this. How much do you get, everybody? Thank you so much, BTS Army Glorians. You have watched the electrochemistry chapter, that means. Thank you so much. So, fusion is answering 10. Should we take the answer 10, everybody? Anybody else who has solved it, please tell me. Please tell me the answer, guys. Please tell me the answer, everybody. Please, 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 please tell me the answer, everyone. Anybody else who has solved it? So, basically, now what do we need? We need Fe2 plus divided by Fe3 plus is equal to how much? 10. Mr. Gamers is saying 10. Fusion is saying 10. Very good. So, correct answer is 10. That means, and is this the correct answer? Yes, 10 is the correct answer. Very good. So, that means now you guys know. Now you guys know what to expect in your exam, isn't it? Yes. Now you guys know what to expect. Very good. Monica Sai, well done, well done, well done. The ratio is 10. Well done. Absolutely great. Chalo. Moving on, guys. Next question. See, similar kind of questions are coming. Basically, you are given a cell. Yes, you are given a cell with the salt bridge and everything. You all know how to denote a cell, right? Then you are given E cell value, you are given E naught cell value, and then you just have to solve the logarithm part. That's it. Nothing much here. I think you all will be able to do this. But chalo, let's do some questions, yeah? Now, here the next question once again seems very similar here, because we are given PTSH2, 1 atmospheric pressure, 1 bar, sorry, 1 bar is the pressure. Then H plus aqueous 1 M. Here you have a salt bridge, M3 plus aqueous to M plus aqueous, and you have here a platinum solid. Okay. Now the E cell for the given cell is 0.1115 volt at 298 Kelvin, when M plus aqueous divided by M3 plus aqueous is equal to 10 to the power A. What is the value of A? What do we have to figure out? We have to calculate the value of A. Okay. Now, first things first. Let us write the equations. Let us find the overall equation. So, we see here that H2 is forming here. H2 is forming here H plus. Do you see that? Do you see that, everybody? Great. So, H2 is forming H plus. That means 2H plus. I have to balance it, right? If I balance it, what happens? H2 becomes 2H plus, right? And here I can see that it must have lost 2 electrons. Great, yes. So where is this reaction taking place? This is definitely taking place as an anode. Reduction, always at anode, right? We remember red cat and ox. Yes. Red cat and ox, exactly. So reduction always at cathode, and anode may oxidation. Anode may oxidation, alright? Yes. Red cat anode, everybody, do you remember it or no? Yes, okay. Chalo, this is that anode. This is an anode. Yes, okay. Now here next one is see M3 plus. M3 plus is forming M plus, right? So that means it must have gained here 2 electron. It must have gained here 2 electron to form M plus. Great. That means this is happening at cathode. This is happening at cathode, right? Very good. So the overall reaction will become 2 electron cancel. Then we will get here H2 plus M3 plus gives M plus plus 2H plus. This is our overall reaction. Agreed everybody? This is our overall reaction. Great. Now what is the formula? Once again everybody, we are going to use the same formula. Do you see the formula is remaining unchanged everybody? So what is the most important formula that you have to learn from this chapter? It is that E cell is equal to E naught minus 0.059 divided by N. What is N? 2 electron. We saw, right? The give and take relationship was by 2 electrons. So 0.059 divided by 2, and then here we go, we have log product M plus, yes, and what is our reactant? Our reactant is M3 plus. Did we have any stoichiometric coefficient? Nothing. So we will leave it as it is, okay? Leaving it as it is. Now what do we have to do, guys? Now what do we have to do? Let's solve it. Chalo. So 0.059 divided by 2 if I do, then how much will I get? How much will I get? And E cell value is also given to you, that is 0.1115, right? Is equal to E naught value is also given to you, I believe. Yes, E naught value 0.2 given to you. Okay. So basically we just have to put it in the, put the values. That's it. So 0.2 minus 0.059 divided by 2. And then we keep it as log M plus divided by M3 plus. Correct everybody? Yes, correct guys? Great. All right. Now, if we solve this part, then what do we get? This will get divided here. So we will get 0.0295 to, yes, 0.0295, yes. Then log M plus divided by M3 plus, correct, is equal to, now 0.2 minus 0.1115 if we do, we will be getting 0.0, one second, I need a little bit of calculator here. We are getting 0.2 minus 0.1115, 0.0885, right? 0.0885. Now what will happen is log M plus divided by M3 plus is equal to, if we solve this, how much are we getting now? Sorry guys, 0.0885 divided by 0.0295. If we solve this, we get is equal to 3, isn't it? And we know that what is given to us, 10 to the power a is equal to 3, right? So a value will be equal to 3 here. Why? Because let me tell you, what are we given? We are also given log M plus divided by M3 plus is equal to 3. That means that since this is given to you, that means that log 10 to the power a is equal to 3. Okay? And that means that a is equal to 3. So that is your answer, everybody. Come on guys, are we here? Very good. Somebody said 2. Fusion, no, it's not 2. The answer is 3, bachu. The answer is 3. It's not 2. Okay, the answer is 2, not 3. I mean, sorry, answer is 3, not 2. Sorry. Okay? Chalo guys, moving on to the next question then. Okay. Following figure shows dependence of molar conductance of two electrolytes on concentration. Lambda m naught is the limiting molar conductivity. Now from here, right here, can you understand which one is what? B is a strong electrolyte, everybody. B is a strong electrolyte and your A is a weak electrolyte, okay? And if we try to make a graph between lambda m and delta and root over C here, then what will happen? Read the statements, okay? Please read the statements here, okay? Alright. So lambda m naught for electrolyte A is obtained by extrapolation. See, if you extrapolate this A, it will be parallel. It will be parallel to your y-axis, right? We cannot do that. But if we extrapolate B, we can find here lambda m naught. So your option A, that is statement A, is incorrect, right? Your statement A is incorrect. Do you see, guys? Option A, that is statement A, is incorrect because for a strong electrolyte, if you extrapolate, you will be getting lambda m naught, but for a weak electrolyte, it will run parallelly to the y-axis. Alright, it will run parallelly to the y-axis, so this will be false. Second, for electrolyte B, you're talking about this, okay? For electrolyte B, lambda m versus root over C graph is a straight line with intercept equal to lambda m. Yes, that is true. I've just told you, if you extrapolate here, you will get lambda m naught. So yes, option B is right. Option B is right. Correct or wrong? Everybody. B is a strong electrolyte. So yes, this makes sense. Okay. Now at infinite dilution, the value of degree of dissociation approach 0 for electrolyte B. Now electrolyte B is a strong electrolyte and degree of dissociation approaches 0 will not be right. This is going to be false, everybody. But lambda m naught for any electrolyte A or B can be calculated using lambda naught for individual ions. Yes, Colruyt's law. What does Colruyt's law say? Colruyt's law states the same thing exactly. So yes, this is right. That means that two statements are right from here. Okay, that means that two statements are right from here. Everybody have a look, guys. Please read the question and understand what is written. Please read the question once. Read the question, everybody. Read the question and understand, everybody. Come on, come on, come on. Yes. Done? Let's move on. Sure. Let us move on, okay? Next question is, guys, are you following? Are you following what I'm trying to tell you? Or you're not? Are you guys following, everybody? Acha, sorry, Fusion. Yeah, sorry. I think I'm getting your chats a little later. There is probably a little bit of lag in the chats. Right? Yes or no? Yes? No? What's up? Sure, no worries. The next question, everybody, is, EPBT, amazing. Okay. The next question is, the equilibrium constant for the reaction ZnS plus Sn2 plus aqueous gives Zn2 plus aqueous plus Sn in solid is 1 into 10 to the power 20 at 298 Kelvin. Now the magnitude of the standard electrode potential of Sn to Sn2 plus if E naught Zn2 plus to Zn is equal to minus 0.76 volt is dash multiplied with 10 to the power minus 2 value. So we have to figure out this value, and given that 2.303 RT divided by F is equal to 0.059. This is almost given to you everywhere, right? Okay. So first of all, what is our reaction going to be? Our reaction is going to be Zn, as it is written here, Zn, yes, plus plus Sn2 plus forms what? It is forming Zn2 plus Sn. And see, it is given here the equilibrium constant. That means that this reaction has to be in equilibrium, right? Yes, this reaction has to be in equilibrium. Now right here, what formula do you expect here? What formula are we going to use? Are we going to use the same formula? In a while maybe, but right here you need the formula delta G naught is equal to minus 2.303 RT log K EQ. Does anybody remember this formula, everyone? Does anybody remember this formula, or anything and everything that I have taught? It's all gone out of your mind. Poof. What is happening, guys? Acha. Now one more thing that you know is, everybody, Don't you know that delta G naught is also equal to minus NFE naught? Do you remember this? Do you remember this? Yes? So that means that we can write it as, everybody, minus NF E naught is equal to minus 2.303 RT log K EQ. Correct? Great. Okay. All right. Acha. Now, although the answer is given to you here, don't worry about it. We will solve the question and then we will check the answer, right? Now, what is given to you? It is given to you that E naught Zn 2 plus E naught, E naught, E naught, Zn 2 plus to Zn, right? So we will write it as Zn to Zn 2 plus, that will be equal to 0.76. This will become, yeah, okay, wait. 1 second. E naught Zn to Zn 2 plus E naught Sn 2, yeah, E naught Sn plus 2 to Sn. This should be equal to 0.059 divided by 2 log KEQ. Now you might ask that where is the minus sign? See, the minus sign will definitely get cancelled out from both the sides. But understand, for E naught Zn, ayyo, how am I writing? Sorry for this bad handwriting. Very sorry. You should be probably giving me some award for this bad handwriting. Anyway, so as I was telling, now that we see what is given to you, the value that is given to you is Zn 2 plus to Zn is minus 0.76 volt. But here what have we written? We have written Zn to Zn 2 plus. That means all we have to do is change the sign and we will write it as 0.76 plus. We do not have this value. We do not have. So we will write it as it is. En Sn plus 2 to Sn is equal to same 0.059 divided by 2 log K EQ. Alright, yes. Where is Q? Where is Q? What is Q? What Q? Where is Q? Where are you finding Q? Mogit. KEQ I'm saying. KEQ. KEQ is equilibrium constant. Arey baba. My goodness. Have you all like kept your brain in the fridge and then you have come? I understand it's winter, but you do not have to keep your brain in this thing, guys. Come on, yeah. What kind of questions you are asking? Have you forgotten everything, like literally the basics of electrochemistry? Hello, people. Not done. Not done. Acha, now we can calculate it from here. E naught Sn plus 2 to Sn is equal to 0.059. Yes, multiplied with everybody. Now calculate this and see what else is given to you. 1 into 10 to the power 20. 1 into 10 to the power 20. And here this is 2. So let's write here 20 because log KEQ is 1 into 10 to the power 20. That means it will be 20 divided by 2. Solve this. How much is the answer? Solve this. How much is the answer? Solve it. 0.059. 0.059 multiplied with 20 divided by 2 is equal to, how much is it coming? Have you made any mistake? What is the answer, guys? Yeah, it should be 0.17. 2 cancels here, 10 here, 0.059. E naught of this is, no, somebody is saying 0.59, someone is saying, Ayush is saying minus 0.17. Are you getting minus 0.17? Nahi to? Wait a second. That's not how we are going to do. Wait. 0.059 0.59 divided by 2 is this, multiplied with 20. No, it's coming as 0.59 only. We have made some mistake, huh? We have somewhere made some mistake. Ooh, hoo, 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 hoo. 0.76 also has to be there, na? No, 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 no. Yes, minus 0.76. Correct. Minus 0.76. Ha, now you will get it. Now you will get it. Now you will get it. Yes. Ha, minus 0.17, isn't it? Yes, yes, yes. Yes. So it will be 0.17. That means that it will become 17 into 10 to the power minus 2 volt. That is the answer. Yes, yes, yes. Yeah, I just did not subtract minus 0.76. Yes. Now it's fine. Now it's fine. Please still check it. Please still check it. Now is everything fine? Everything. Please correlate the answer once with your answer as well. Correlate the answer once. Everybody. Is there any hits and misses? No, now that we have received the answer already, I don't think so. There should be. है ना? It's all cool? Yes, Vaishnavi, thank you so much, beta. Thank you so much. Mr. Gamers, the formula and everything is correct. We just had to answer, we just had to subtract minus 0.76. Okay. Can JEE ask from out of syllabus? I do not know. Dilipan Raj. I don't think so JEE asks out of syllabus, but definitely the syllabus is vast and there are a lot of questions which requires you to do a little bit of higher order thinking. So those kind of questions, it will be a little twisted. So be prepared. I don't think they will ask you out of syllabus, but if they do, then you can definitely raise it and then they have a look at it. Okay, but the chances of an out of syllabus question, it's very rare. I do not think they will do that. Okay. Chalo guys, next question. Are we ready? Your next question is the electrode potential of the following half cell at 298 Kelvin. X to X plus 0.001 molar salt bridge, Y2 plus 0.01 molar to Y is dash multiplied with 10 to the power minus 2 volt. You have to solve it for the nearest integer. And what is given to you? E naught x2 plus x is equal to minus 2.36 volt. And E naught y2 plus 2y is equal to plus 0.36 volt. Now 2.303 RT divided by F is equal to 0.06. See, in every question, do you see, in every question, they're actually giving you the value. So please be very careful. If you are given 0.059, consider it 0.059. If you are given 0.06, consider it to be 0.06. All right. Yes. So as per the question, we have an equation here. What is the equation? Our equation is x plus y 2 plus, yes, gives us y plus x 2 plus. Make sense, everybody? Is this the equation that we get? See, x to x plus, and here do you have, here what do you have? You have y2 plus 2y. So x plus y2 plus gives y and x2 plus. Correct? Great. Okay. Same formula. This time we are using the same formula, that is E naught cell is equal to directly let's write no E naught y2 plus y2 plus 2y is given 0.36. So directly let's write here 0.36 minus 2.36. Yes, that will be equal to what? 2.72 volt. What did we do? E naught cell is equal to what? Cathode minus anode. No, that's all that we have done here. That's all that we have done here, isn't it? Cathode minus anode, that's it. So you get E naught cell. E naught cell is equal to 2.72. Okay. Now let us calculate E cell is equal to E naught cell minus that 0.059, right? But instead here we are given 0.06. So E cell is equal to 2.72 minus 0.06 divided by how many electrons, bacha? How many electrons here? 2 plus 2 plus. That means definitely 2 electrons. Yes. So directly we will write here 2. Alright. Now log of, see, Log of what is given to you? Product 0.01. Reactant you have 0.001. Cannot even say product and reactant right here, because have a look. X to X plus, that means X to X plus. This is X2 plus here, right here. This is 0.001 molar. So this becomes your product, right? And here, what do you see? Y2 plus to Y. This is right here 0.001 molar. So here what will we write? We will write it as log of 0.001 divided by 0.01. Please have a look, everybody. Are you all understanding this much? Everybody is understanding this much? Great. Okay. Now, if we solve this, we will get 2.72 minus 0.06 divided by 2. That means this will become 0.03. Yes. And what will this log value be? What will this log value be? Come on, you know this. You know this, everybody. You know this, everybody. Chalo. Right here, what do we write? 2.72 minus 0.03. Or 2.75. Huh? 2.75. This will be plus. It will be 2.75. So 2.75 bole to 275 into 10 to the power minus 2 volt. Correct? Correct? Can you explain the question? Sheikh Khaja, you are asking me to explain the question. Chalo, I'll tell you, bacha. The question is the electrode potential of the following half cell at 298 Kelvin. In electrochemistry, we study about basically batteries, okay? Batteries and singular form cell. In a cell, there are two halves of the cell. One side is your reduction half, other side is your oxidation half. Now, in this case, what they have done is they are giving you X to X2 plus. Now, you tell me that when X forms X2 plus, that means it is losing electrons to become X2 plus. When something loses electron, then what happens? We all know that oxidation is loss of electrons. So, right here, oxidation is happening. This is your oxidation half. That side, Y2 plus is forming Y. Y2 plus is gaining 2 electrons to form Y. So reduction is, yes, reduction is gain. Oil rig. Do you remember? Oxidation is loss of electron, reduction is gain of electrons, right? Yes. So here what is happening? This is your reduction half. Yes. And for both of them, you are given 0.01 molar, 0.001 molar. That means the concentrations are also given to you. Am I making sense? Yes, you are also given the concentration. After that, now they are asking is that what is the electrode potential? You had to calculate electrode potential. Electrode potential bole to E cell you had to calculate. What is the formula? We now know that E naught cell is equal to cathode minus anode. That is what we have done. See, you are given the value. You are given the value here plus 0.36 minus 2.36. Once we have subtracted it, we get 2.72. Right? Now, in E cell value is E naught cell minus 0.06 volt divided by 2. What is 2? 2 is N. N is basically how much is the give and take of the electrons. How many electrons actually were given or taken. So, you have written it here. Now, log of 0.001 divided by 0.01, if you solve all of these, you will be getting here 2.72 plus 0.03 is equal to 2.75. Are you getting the answer now? Yes, are you getting the answer now, everybody? Are you all getting the answer? Do you understand this now? Do you understand this now, everyone? Or no? Any other doubt? Any other doubt? Guys, this particular thing is equal to minus 1. That is why 2.72 plus we have written it as 0.03. Got it? Clear? Any doubt here? Clear? Clear, bachos? It is 275 multiplied with 10 to the power minus 2 volt. Okay? Yes, Mithilesh also understood. Who else was it? Sriram, did you understand? Tarun, did you understand? Yes, Tarun, what was your question? I think I'm replying. I cannot see. Such an alpha question. Arey wow. If you're finding this to be alpha, very good. I'm super proud of you. Chalo guys, next question. See, everybody, you have to understand one thing, that to solve electrochemistry and redox reactions, just know your simple log formulas, okay? Please pay a little attention in Nabamita Ma'am's class so that you understand how to solve these log problems and you will be able to do outstanding here. Yes, Lalu, you are spamming a little too much, bacha. Please do not spam, okay? Please do not spam. And I have just repeated the question, so if you want me to repeat it again, I will not be able to do that. We will be late here. Why don't you rewind it and watch it again? Chalo guys. Now, next question here. This is also a JEE Main 2023 question. The logarithm of equilibrium constant for the reaction palladium 2 plus 4Cl minus gives PdCl4 2 minus is dash. Yes, what is given to you? 2.303 RT divided by F is given to you as 0.06 volt. Yes, and Pd2 plus 2 electron gives you Pd solid. For this case, the E naught value is 0.83 volt. That is given to you. Now PdCl4 2 minus in aqueous plus 2 electron forms PdS plus 4Cl minus. And in this case, the E naught value is 0.65 volt. So certain things are given to you. Okay? Certain things are given to you. Tarun, you will have to watch the whole form. Yes, whole chapter. Yes, otherwise it will be very difficult. Okay? Now, everyone, first things first, what is the reaction that is given to you? The reaction right here is Pd plus 2, yes, Pd plus 2 electron will give us Pd, right? And for this we are given E naught value which is equal to 0.83 volt. Am I right? Am I right? Yes, we can see that. That is given to you in the question. That's exactly what I've written, everybody. That's exactly what I've written. Now, next part is, everybody, have a look. Pd plus 4Cl minus. Okay? Yeah? That forms PdCl4 2 minus. Alright? Now here Pd has come to Pd plus 2. Right? So I have to write here 2 electrons. Cool. Alright. Yes. And right here E naught is equal to, it is given 0.65. So I'm going to write it down here, 0.65. Clearly these two electron will get cancelled. So our overall reaction will become, Pd plus 2, yes, plus 4Cl minus, yes, who will give us PdCl4 2 minus. Am I right, everybody? Yes. Now, as per our previous question, just some time back, we got to know that E naught cell. How do we calculate E naught cell, bachu? E naught cell is equal to E naught cathode minus E naught anode, isn't it? This is the formula, everybody. Is this the formula? I have just taught you. So everyone, here E naught cathode is 0.83 volt and E naught anode is 0.65. So 0.83 minus 0.65 is equal to how much? Is equal to 0.18. Am I right? Yes, 0.18, everybody. Will it be 0.18? Yes. Okay. Now, clearly you can also see that your n is equal to 2, right? Let's call this as equation 1. Now let this be 2. Okay, n is equal to 2. Alright. And what else is given to you here? Now what do you have to calculate? Logarithm, log value you have to calculate. Log of equilibrium constant for the reaction. Okay, I am almost done with everything, bachos. Almost done with everything. Now, can you tell me what are we supposed to do? This is the last bit of it, guys. The last bit of it, everybody. Wait. No, wait. The last bit of it, everybody. Now we know that delta G naught is equal to minus RT ln of K, isn't it? And delta G naught, just some time back only I taught you that delta G naught is equal to minus NF E naught cell. Do you remember? Minus NF E naught cell, correct? Yes. which is equal to minus RT. Ln of k is, ln of k will be what? Ln of k to ln of k to log. If we have to convert, we will have to do 2.303 multiplied with log k. Am I right? This is what we do. This is what we do. Now, if this is the case, I'm continuing here, everybody, continuing here. Please check it out. So that means that E naught cell is equal to E naught cell is equal to here minus RT into 2.303 RT, and F, if I bring here, that will be equal to 0.06, right? So that means I can write it as E naught cell divided by 0.06. Yes, that is equal to log k here. And here, what do we not know? We do not know something, right? We have, Acha, let us consider that to be x here. Now can we calculate? Shriram has given me the answer. Yes. No, I did not miss any sign, Mithilesh. No, I haven't missed any sign. Have I? No, I haven't missed any sign. No, it's absolutely fine. Yes, for redox reaction also you must watch it. Okay, so now what you have to do is, from these three equations, see, log value, E naught cell value you have. E naught cell is 0.18 divided by 0.06 multiplied with x value you do not know, right, is equal to log of k. Is this x or n also you can take it, right? Yes, TK, absolutely right. Arey Baba, but minus will get deducted, no? This minus and this minus, it gets cancelled out, right? It gets cancelled out, isn't it? It is fine. I'm doing it right only. I don't know why you were confused. 6. GK is also saying 6. Is it 6? You guys can see the answer here. Can you? Chalo, answer is 6. Everybody is saying answer is 6. Answer is 6. Let me also calculate. Yeah. Can't take your answer for face value. Wait a second. Yes, answer is 6. Yes, answer is 6. Oops, dropped something. Yes, answer is 6. Very good. Okay. Shall we move on to the next question then? Chal. Next question. Oh, this seems easy. The resistivity of a 0.8 molar solution of an electrolyte is 5 into 10 to the power minus 3. Yes. All you have to do is, for x is equal to 2. That means you can also write it as n. Just write it as n. That will be easier. Why to use another n? Yeah. X, n, whatever. Yeah, same thing. It's just a variable. Write it. The resistivity of a 0.8 molar solution of an electrolyte is 5 into 10 to the power minus 3 ohm centimeter. What is the molar conductivity? Dash into 10 to the power 4 ohm to the power minus 1 centimeter square mole to the power minus 1. Okay, what is the formula? We know that our formula is lambda m is equal to kappa multiplied with 1000 divided by n. Right? What is kappa? Now kappa is equal to 1 divided by rho. Am I right? Very good. So that means that lambda m is equal to 1 divided by resistivity, 5 into 10 to the power minus 3. What is rho? Rho is your resistivity. So 1 divided by 5 into 10 to the power minus 3 and multiplied with 1000. Yes, divided by 0.8 molar, that is given to you. So divided by 0.8 molar. Calculate this. How much will you be getting? Calculate this. How much will you be getting? Everybody, come on. Calculate this and tell me how much will you be getting. 1000, 10 to the power minus 3 here, right? 5, 0.8, 5 here, cancel, 0.8, 10 to the power minus 8, 200 here. That means I think it should be equal to 0.25 minus 3, 200. These two will get cancelled here. No, these two will not get cancelled here. 200, 0.25 multiplied with 10 to the power 6. Am I right? 0.25 into 10 to the power 6. Now that means lambda m is equal to, what do we want? 10 to the power 4 we want. If we want 4, that means 25 multiplied with 10 to the power 4. Yes, ohm to the power minus 1, centimeter square, mole to the power minus 1. Am I right? This is the answer. 25 is your answer, guys. 25. See, this was very easy, very simple, right? Yes, this was very simple, very easy. You could easily do it. Am I right? You could easily do it. You just have to put it in the formula. So if this kind of formula questions come, then you will be able to easily do it. So there are 2 or 3 formulas. What are the things that we have understood? We have understood how to calculate E naught cell, how to calculate E cell, how to calculate delta G naught. Yes, and delta G naught has another formula, that is minus NF E naught cell. Right? So these 2 formulas you have to remember. Second, now you have to remember is lambda m is equal to kappa multiplied with 1000 divided by molarity. What is kappa? Kappa is equal to 1 by rho. Right? And apart from this, one other formula that you have to remember is your Nernst equation. That's it. You don't have to remember anything else. From this, if you do these formulas, then your electrochemistry chapter is sorted. Okay? Alright. This is the Pathfinder, which is the best book physical chemistry for JEE. Are you asking for 2025 or 2024? If it is 2024, do not start a new book right now. It is absolutely foolishness to start a new book right now. You won't be able to understand anything. It will rather be a loss than being your than being beneficial. If it is for 2025, then please start reading N Avasthi. However, before that, please complete your NCERT. Okay. Yes, please follow your NCERT first and then complete your N Avasthi. Okay, I have just told you, bacha, just told you. Chalo. Next question. At what pH given half cell MnO4 minus 0.1 molar to Mn2 plus 0.001 molar will have electrode potential of 1.28 volt. So guys, can you see here what is happening is you are getting an equation. MnO4 minus forms Mn2 plus, right? Yes, this is 2 plus. MnO4 minus, can somebody tell me what is the oxidation state here? This is going to be in plus 7. So plus 7 to plus 2 oxidation state. That means there is a give and take relationship of 5 electron. Yes, 5 electron. Now what will happen? There are 4 oxygen here. 4 oxygen. So can I write here 4H2O? If I write here 4H2O, now we are only left with 8 hydrogen plus. 8H plus. Am I right? Is the equation balanced, everybody? Have a look. Have a look. Is the equation balanced? It is, right? Now what do we know, guys? We know the formula, the usual formula. E is equal to E naught minus 0.059. That is the value that we are taking. Yes. Divided by how many electrons? How many electrons? 5 here. So we will be writing here 5. Okay. Alright. Now log of product. Product is Mn2 plus. Am I right? Divided by reactant. What is our reactant? Our reactant is MnO4 minus, and this side you have 8H plus. So H plus raised to the power 8. Am I right, everybody? Am I right, everybody, guys? This is making sense? 5 electrons. Very good, everybody. Yes, awesome. Okay. Now E value is given to you actually. See, electrode potential is given to you as 1.282. Okay. So all you have to do is substitute now. 1.282 is equal to E naught value, everybody. E naught value is, see, 1.54. Since they are writing here, they have not written anything else on the other side. Sorry, guys. Let me drink some water. Let me drink some water. Sorry. Now, because there is nothing else given to you, that means you will consider that it will just be 1.54 volt. Okay, so write it down here. E naught value will become 1.54 minus, as it is 0.059 divided by 5. Yes, log of, now everybody, mn2 plus, see that is given to you, mn2 plus is 0.001. 001 can be written as 10 to the power minus 3, ain't it? Can we not write it as 10 to the power minus 3? Because we are given 0.001 molar, that means the concentration can be written as 10 to the power minus 3. Right, very good. Okay. Now what do you have? This side you have 0.1. 0.1 can be written as how? 10 to the power minus 1 multiplied with h plus to the power 8. Okay? Yes? Now remember, we have to calculate the pH. We do not know the pH. We have to calculate the pH, right? So till here we are done with. Now we have to do what? We have to solve it a little further. Now what do we do? 0.059 divided by 5, right? And here you have 1.282. So 1.282 minus 1.54, how much will you be getting? 1.282 minus 1.54, how much will you be getting? Come on guys, answer. 1.282 guys. 1.282 minus 1.54. Anybody? Reply guys. Anybody? Nobody is replying. 1.282 minus 1.54. You will be getting how much? I'm still not getting any answer guys. Nobody is going to answer? Chalo, what to do? I will only answer. Since I have to take a class, it is my duty only to answer you. But you guys are not going to answer me. I have understood that. Chalo. 0.258. This is what you will get. Minus 0.258 multiplied with 5 divided by 0.059. Okay. Is equal to 10 to the power minus 1, 10 to the power minus 3 log 10 to the power minus 2 divided by h plus to the power 8. Right? Now, solve this part. How much will you be getting? Solve this other side. You are answering. Then why am I not able to see it? Solve this and tell me. Solve this guys. Solve this. Till that time, let me do here the rough for you. Now see, log of 10 to the power minus 2 is equal to log h plus to the power 8. Right? That means that minus 2 plus 8 is going to be your pH. So that is equal to log of h plus. Minus 2 and plus 8. pH. Yeah, that's it. That's it. Now, coming back to it. Somebody said 0.742. 0.742. Where are you getting 0.742? I don't think so. It should be 0.742. No. Calculate it again. 0.252. This divided by 21.86. That's what I am getting, guys. I am getting 21.86 is equal to minus 2 plus 8, and that's your pH. Now if you calculate this further, your pH is equal to how much now? Now how much will you be getting? 3. Shriram is getting 3. I am not going to take your answer. Wait. 21.86. 21.86. Yes, I'm getting 2.985 which is almost equal to 3. So your pH is 3. Your pH is 3, everybody. Please check it out. Everybody is getting the same answer? Everybody is getting the same. Very good, Ayush. Very good. Very good. Yes. 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 This is what you get. 2.985, which is almost equal to 3. That is your nearest integer. Okay. That is your nearest integer. Chal. Next question, everybody. 1 into 10 to the power minus 5 molar AgNO3 is added to 1 liter of saturated solution of AgBr. See, everybody read the question. You are given the concentration of 1 into 10 to the power minus, please read this question. See, you are given molarity is given to you 1 into 10 to the power minus 5 AgNO3 is added to 1 liter of saturated solution of AgBr. The conductivity of this solution at 298 Kelvin is dash into 10 to the power minus 8 Siemens m to the power minus 1. Now given KSP AgBr is equal to 4.9 into 10 to the power minus 13 at 298 Kelvin. Alright. Lambda naught Ag plus is equal to 6 into 10 to the power minus 3. Same unit. Lambda naught Br minus is equal to 8 and lambda naught NO3 minus is equal to 7. Chalo. This will take us a little longer time, everybody. So please pay attention and have a little patience. Okay. First and foremost thing, everybody, what do we know? We know that AgNO3. If we take AgNO3, how will it dissociate? How will it dissociate? It will dissociate as Ag plus NO3 minus. Right? Now, it is stated in the question. In the question, everybody, it is written that you are taking 1 into 10 to the power minus 5 molar. So, if you take 1 into 10 to the power minus 5 molar, if that is your concentration, that means if AgNO3 dissociate, you will be getting 10 to the power minus 5 and 10 to the power minus 5. Baba, 1 into 10 to the power minus 5 is as simple as 10 to the power minus 5. Do I make sense? I do, right? So, if I take 1 into 10 to the power minus 5 molar of AgNO3, it will dissociate and I will get 10 to the power minus 5 Ag plus and I will get 10 to the power minus 5 NO3 minus. Am I right? Yes. Now, let's take AgBr. If I take AgBr, then AgBr is going to dissociate as Ag plus Br minus. Now, KSP is given to you, everybody. KSP of AgBr is given to you and we know that KSP is equal to Ag plus concentration and here Br minus concentration. Am I right, everybody? Do you guys remember this? Do you guys remember this? So from here I can write, from here because of this equation now I can write Br minus is equal to KSP divided by Ag plus. Yes, right? Now what is KSP? KSP is given to you as 4.9 into 10 to the power minus 13 divided by what is Ag plus. Ag plus you already know it is 10 to the power minus 5. We have just figured it out. So all you have to do is 10 to the power minus 5. Now what you have to do is this gets cancelled, this gets cancelled. So now you will have 4.9 multiplied with 10 to the power minus 8. And that is for Br minus. Hai na? That is for Br minus. Great. Now similarly, everybody, guys, we will have to calculate it for, wait a second. Let's draw a line here, okay? Now let us do it for Ag plus, okay? For Ag plus now, what is given to us and what we have to find out? Lambda m is equal to, we know, kappa divided by 1000 into molarity. Okay? Alright? No. Wait. 1 second, guys. 1 second. Ag plus, chalo, 4.9 into 10 to the power minus 8. We have figured it for Br minus. Now what do we have to do? Br minus lambda naught is given. Now we are trying to figure out lambda m first. If we figure out lambda m first, then we have to do it for K divided by 1000 into molarity. Yes? K divided by 1000 into molarity. And what will that give us? What is lambda m given to you? 6 into 10 to the power minus 3. K of Ag plus. K of Ag plus. One second, guys. Lambda m. So, okay. Here we have to write here K Ag plus divided by 1000 multiplied with m. Okay. Now, lambda is given to you. Lambda is given to you. So, this is 6 into 10 to the power minus 3 is equal to KAG plus divided by 1000 into 10 to the power minus 5. Am I right? Everybody? Yes? Yes. Right. Okay. KAG plus divided by 1000 into M. Okay. Alright. So that means that from here KAG plus is equal to 6000. This will be 6000, right? 6000 into 10 to the power minus 8. Correct? Yes? That's it? That's it. Shriram, please check now if this is right. If this is right, then now we have to do it for BR minus. Now we have to do it for BR minus. Chalo, let's do it similarly. We have 8 into 10 to the power minus 3, isn't it? 8 into 10 to the power minus 3 here. Yes, so 8 into 10 to the power minus 3 is equal to K BR minus divided by 1000 into 4.9. Here, we have figured this out. See, 4.9 into 10 to the power minus 8. If you calculate this, how much will you be getting? KBR minus 4.9 into 8. 8 4s are 32. 32 and here it is 8 9s are 39.2. 39.2 into, this is what you should be getting. Check again. Mr. Gamers is saying correct only, no? Am I not correct? Wait a second. Wait. I think we are almost done, guys. Finally, for KNO3 minus, we know that it is 7 into 10 to the power minus 3. So that means this will be equal to 7000 into 10 to the power minus 8. Similar to this. है ना? Yes. Now, we need to find solution. We need to find the conductivity of the whole solution, guys. We need to find conductivity of the whole solution. So, K of solution is equal to 6000 plus 7000 plus 39.2. I think that 39.2, wait a second. No. Here have I made any mistake? This is minus 8. So this is minus 3. This is 1000. 8000 into 4.9 is this. Huh. Minus 8. This is common. Now what is the answer that you are getting, everybody? Have a look and tell me. What is the final answer you are getting? That you calculate. The final answer. I think it is correct only. What is it that you asked me to check? Mithilesh, please tell me what is it that you are asking me to check? What is it that you are asking me to check? Everything is fine only, right? 13039.2. Okay. Done. K into 1000 divided by M. So this is equal to into 10 to the power minus 8. So that means that this is almost equal to 13.0 something something. That will be equal to 14. kAg plus. Have I made a mistake? No, it's fine only. What is the mistake? Where do you see the mistake? Check it out, check it out, check it out, check it out and tell me. Check it out and tell me. K into 1000 divided by M. रुको रुको रुको. K into 1000 divided by M होता है ना? That means that now if you calculate, what will you be getting? This will go here. 10 to the power minus 5 this. And 6 divided by this. You said before. Did I not see? Wait a second guys, let's do this again here. There is a lot of calculation error. Wait a second. But you guys get the point how to do this. I think I've done some calculations. See, this is the problem when you are weak in mathematics and you have to study chemistry. You guys don't have to be like this. Chalo, yes. So what was our this thing? What was our problem here? We know that lambda of Ag plus, right? What did we have to do? Yes, yes, Sriram, you did say it before. You did say it before. You did say it before. True, true, true. Acha, now let's try to solve it, everybody. Come. Come with me here. Solve it with me now. Tell me, what do we have to do? What do we know? We know that lambda m is equal to k multiplied with 1000 divided by m. So we know here 6 into 10 to the power minus 3 is equal to, what is it? K value is what? K we do not know. K we do not know, multiplied with 1000 divided by molarity we know. Molarity we know, that is equal to 10 to the power minus 5. Yes, now calculate. Now calculate. Tell me. Why would I do that? Now calculate this. What is it? K value is how much now? What is the K value for Ag plus? K for Ag plus, please check and tell me. Calculate this. Guys, come on, quickly, quickly, quickly. Hi, Creo King. After such a long time, how is your preparation going on? How is your preparation going on? After such a long time, yeah, bachu. Such a long time here you are. Is somebody done? Six. Are you getting 6? 6. 6 into 10 to the power minus 11. Chalo. Next, similarly you do this and then you have to add them. Okay? You have to similarly calculate it for the other ones and then you have to add them. Chalo, let's do the next one also. Now let's do it for BR, isn't it? We have to do it for BR. So again same. This time what's the value? 8 into 10 to the power minus 3. 8 into 10 to the power minus 3 is equal to K into 1000 divided by, here the value is 4.9 into 10 to the power minus 8. Now calculate. Now calculate how much are you getting. This time how much are you getting, everybody? Yes, Aravindan. Yes, Creo. Yes, Vishwajit Pal. Yes, John Rufus. Everybody. You are right. 6 into 10 to the power minus 11. Now calculate this. This is for BR minus. And similarly, now finally, you will also calculate for 7 into 10 to the power minus 3 is equal to K into 1000 divided by, what is your M here? 10 to the power minus 5. Calculate all of them. Calculate all of them, and then K of solution is equal to add. Okay? And then what is your answer? Tell me. These three things you tell me now. These three things you have to tell me now. Come on, guys. How much? 39.2 into 10 to the power minus 14. This is the second one. Minus 14. Okay. And the last one for NO3 minus. For NO3 minus, I believe you will be getting 7 into 10 to the power minus 11. Now just add all of them and calculate. Just add all of them. How much will you be getting? 6 plus 7. Done, guys. Chalo, I think let's move on. This question is over, right? It has taken us a long time. Let's move on to the next question here. 7 into, yes, Aravindan, you will get that only, yes. You will get that. No, Vishwajit, I don't think you are getting 10.92. Are you getting 10.92? Are you getting 10.92? I don't think so. It should not be 10.92, but chalo, let me check, because you guys are having a confusion. That's why I'm checking. 8 into 4.9 is directly 39.2 here. So 10 point minus 8 and 3. From here minus 3, here it goes minus 5, it will become. Minus 5 it will become. And then here this side is. Guys, are you sure this is 10 to the power minus 14? Check it out, ek bar. Now what is the correct answer? Move on to next one, hai na? This has taken a lot of time. Calculations, I believe you can do it. Chalo. Next question, everybody. Let's do this. The correct order of reduction potential of the following pair is, okay, this question, there is no other easy way. One direct way to do this is, you have in NCERT, everybody, you have this list. This table is present in your NCERT. Now what you have to do, you have to just correlate the data and write that down. The first one that you have here is, have a look, Cl2 to Cl minus. Cl2 to Cl minus, where do you have Cl2 to Cl minus? See, right here you have. Right here. 1.36. 1.36 is the value. Okay. Next what do you have? I2 to I minus. Do you have this? I2 to I minus. Yes, you do. I2 to I minus is 0.54. Alright. Next, Ag plus to Ag. Ag plus to Ag. Where do you have Ag plus to Ag? Yes, Ag plus to Ag is right here. 0.80. Alright. Yes. Okay. Next, what do you have? Na plus to Na. Just remember this. Na plus to Na plus to Na. Na is right here. Minus 2.71, guys. Minus 2.71. Alright. And finally, the last one is Li plus to Li. Li plus is at the end. The last one is Li, everybody. So minus 3.05. Now you have to put it up in an ascending order, right? That's what they have asked. Yes, they have asked you the correct order of reduction potential of the following pairs. Correct order. So obviously 1.36 is the highest. That means A is first, right? Wait. I'll move this side. Yes, 1.36 is the highest. Then you have 0.80. So A is greater than B. Then you have 0.54. That is greater than C. Or no? 0.54 is for, wait. A, then C, then B, and then what do you have? Then you have D and E. D and E. Is that right? Is that what you guys are getting? Yes, some of them are. No, not today. Today I'm not taking any advanced question. Today I'm only taking JEE Main's question, bacha. A, C, B, D, E. Is that the right one? Please check it out, guys. Hana, I had given you some, this thing. I had given you a mnemonic, right? Haven't I? I think I had given you a mnemonic here, haven't I? If I haven't, then let me think about it. Then I will come. Chalo guys, next question. The dou E by dou T at constant pressure of different types of half cells are as follows. For A, it is 1 into 10 to the power minus 4. For B, it is 2 into 10 to the power minus 4. For C, it is 0.1 into 10 to the power minus 4. And for D, it is 0.2 into 10 to the power minus 4. But this is a very easy one. See, whenever you are taking a cell, you have to have less variation in EMF, okay? You have to have less variation in EMF with temperature. Alright. So that means whichever has the least value, you will opt for that. Whichever has the least value, you will opt for that. Now, which one has the least value? So that means option C. Option C is the correct one. Whichever has the least value, that is the one that you will take, because you do not want much deviation of dou E by dou T at constant pressure. You do not want deviation from there, which is why whichever has the least value, that means it will deviate less, and that is why you will opt for that. So option C has the least value, and that is the answer. Okay, that is the answer. Yes, Crave, I only take it in this thing, only in English, bacha. Yes. Sham edits, I'm so sorry, bacha. I do not know right now. It's not there in the top of my mind, okay? I do not have it at the top of my mind right now. Chalo. Moving on, guys. Next question. Which one amongst the following are good oxidizing agent? Which one amongst the following are good oxidizing agent? Now let me tell you a trick, everybody. Just have a look. All of them are lanthanides. Lanthanides have a common oxidation state of +3, isn't it? Yes. They have a common oxidation state of +3. So that means samarium from +2, it will try to go to Sm +3. That means what is it doing? It's losing electron, right? If it is losing electron, that means what is happening? Oxidation is happening here. So that means this is not going to be an oxidizing agent. If oxidation is occurring here, are they going to be oxidizing agent? No. No. Similarly, for cerium also, cerium is in +2 oxidation state. From here, it will try to go to +3 oxidation state. Not gonna work out. But for both Ce +4 and terbium +4, these two will try to go to the common oxidation state of +3, and while doing that, what is happening? They are, now what are they doing? What are they doing, everybody? Yes, these two are going to be a better oxidizing agent. These two are going to be better oxidizing agent, right? Because why? They are gaining electrons right now. From +4 to +3, they are gaining one electron, isn't it? Yes, it was in +4, gained one electron, went to +3. So these two are going to be your oxidizing agent. Am I right? That means that option C and D. Yes, option C and D is the correct answer. Very good, everybody. Very good. Alright, chalo. Moving on, guys, next question. An indicator X is used for studying the effect of variation in concentration of iodide on the rate of reaction of iodide ion with hydrogen peroxide at room temperature. The indicator X forms blue colored complex with compound A present in the solution. The indicator X and compound A respectively are starch and iodine, methyl orange and hydrogen peroxide, starch and H2O2, or is it methyl orange and iodine? All right. Yes. So that means everybody, let us have a look at it. Okay. Now here what are they saying? They're saying that indicator X is used for studying the effect of variation in concentration of iodide. So here iodide ion is basically oxidized to iodine, isn't it? Is that what they're saying? Indicator X is used for studying the effect of variation in concentration of iodide on the rate of reaction of iodide ion at this thing. Indicator X forms blue colored complex. Okay. So iodide ion is basically oxidized to I2, which obviously gives you a blue color, isn't it? When? With a starch indicator. So obviously option A, starch and iodine. Iodide ion is oxidized to I2, which is a blue color thing. And when are you getting blue color? When iodine reacts with starch, that's when you get a blue color. So yes, that is the correct answer. Right? That is your correct answer, everybody. Chalo guys, moving on. Oh, thank you so much, Kirtana. Thank you so much, bacha. Chalo, next question, everybody. When Cu2 plus ion is treated with potassium iodide, Ki, a white precipitate X appears in solution. The solution is titrated with sodium thiosulfate. The compound Y is formed. X and Y respectively are. Chalo, Cu2 plus ion. Cu2 plus is treated with Ki. How do we write Ki? Ki can be written as I minus. I minus, can we write it as I minus because K plus I minus, right? This will form Cu2I2. If it is Cu2I2 here, Cu2I2, plus it forms I2 also. Cu2I2 plus I2. That means here we will have 4I minus, right? And here Cu2, that means here it will be 2Cu. This particular product is white precipitate. This is your white precipitate. Now what are they saying? The solution is titrated with sodium thiosulfate. The solution is treated with sodium thiosulfate. So sodium thiosulfate is Na2S2O3. Right? If you titrate it with sodium thiosulfate, and here that means you are supposed to have I3 minus. I3 minus plus Na2S2O3 will give you 3I minus plus 3I minus, and you will get Na2S4O6, right? You will get Na2S4O6. That means option B. Option B is the correct answer, guys. Option B is your correct answer. Next question. Which one of the following is an example of disproportionation reaction? Alright, this is going to be very simple, very easy. See, 3MnO4 2 minus. MnO4 has plus 6 MnO4 2 minus, so plus 6 oxidation state. Plus 6 to 2 MnO4 minus. MnO4 minus, if it is MnO4 minus, then this is plus 7 oxidation state, and MnO2 means it is plus 4 oxidation state. So plus 6 to plus 7, what is this? This is oxidation. This is oxidation. And plus 6 to plus 6 to plus 4, this is your reduction. Clearly this is a disproportionation reaction. Clearly this is a disproportionation reaction. So option A is definitely the correct answer. Rest of the ones, then can you please, rest of the one, that is option B, C and D, can you please check, choose. Please check the B, C and D. Are they also disproportionation reaction? Please have a look. Are they also disproportionation reaction or not? Absolutely. In same reaction, one single element has to go through oxidation as well as the reduction simultaneously. One single element. And here in this case, Manganese from +6, it is going through oxidation and forming Mn +7. It is going through reduction and it is forming +4 oxidation state. That means that this is clearly a disproportionation reaction. Chalo. Next question. Which of the following has the least tendency to liberate hydrogen from mineral acids? Oh, even without reading the question, you can write it that it has to be copper. Copper can never displace hydrogen from mineral acid because copper is below hydrogen in electrochemical series, isn't it? Copper is below hydrogen in electrochemical series, so copper cannot displace hydrogen atoms. That's something that you can, without even picking up your pen, you can answer, okay? Alright, without even picking up your pen, you can answer. Chalo guys, moving on to the next question. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Permanganate titrations are not performed in presence of hydrochloric acid. Chlorine is formed as a consequence of oxidation of hydrochloric acid. In the light of the above statement, choose the correct answer from the option given below. Guys, what do we know? Our reaction that we know is, see what are they saying? Permanganate titrations are not performed in the presence of hydrochloric acid. Chlorine is formed. Okay, so basically permanganate, that means 2KMnO4, right? Potassium permanganate. Plus we have to take hydrochloric acid. If we take this, then what will we get? We will get MnCl2. MnCl2 we will get. Plus we will get some amount of KCl. We will get some amount of KCl, right? Apart from that, what other things will you get? You will also get H2O. There will be H2O. Plus you will get some chlorine gas as well. So yes, HCl gets oxidized by KMnO4 into Cl2. That means that both the assertion and the reason are correct, and yes, our reason is the correct explanation of the assertion. So option A is the correct answer. Okay, option A is the correct answer. Chalo guys, moving on. Next question. We want memory series. What is memory series? What do you mean by memory series? What do you want us to do in memory series? In neutral or faintly alkaline medium, KMnO4 being a powerful oxidant can oxidize thiosulfate almost quantitatively to sulfate. In this reaction, overall change in oxidation state of manganese will be. Okay. This is going to be easy, not so difficult, everybody. I think we can do this. Right? So what I say, in neutral or faintly alkaline medium, guys. Neutral or faintly alkaline medium, I hope that you know it. Basically, what are we going to do is MnO4 minus. KMnO4 can be written as MnO4 minus, right? Yes, MnO4 minus. What are we taking? Thiosulfate. So S2O3 2 minus. Right? Plus H2O we will take, and that will give us MnO2. Yes. Plus it will give us SO4 2 minus, right? And we will get 2OH minus, right? Because it's in neutral or faintly alkaline medium. Now here Mn is in +7 oxidation state. 2 it goes to +4 oxidation state. So 7 to +3 +4 is how much? 3. That means option D is the correct answer. That means option D is your correct answer. I'm so sorry guys if you constantly feel like, closing your ears because of my cough. I'm really sorry, but I have to take the class. I cannot, like right now your exam is right around the corner, and now even if you fall sick, unless and until it's not the situation that you are not able to get up from the bed, I think we should take the session, isn't it? We should not be cancelling the session at all. So yes, we are going to put in that much effort. You should too. So should you. Okay. Chalo guys, next question. A 2.0 gram sample containing MnO2 is treated with HCl liberating chlorine. The Cl2 gas is passed into a solution of Ki and 60 ml of 0.1 molar Na2S2O3 is required to titrate the liberated ion. the percentage of MnO2 in the sample is dash. Okay. So basically what do we say? We say that 60 ml of 0.1 molar Na2S2O3, right, should be 2.0 gram of sample containing this Cl2. So this means that if 0.1 molar Na2S2O3 we take, yes, if we take Na2S2O3 of 0.1 molar, that means we can also say that 60 ml of 0.1 normal of Na2S2O3, right everybody? Yes. And that means, this means that 60 ml 0.1 normal I2, this is equivalent to 60 ml 0.1 normal Cl2. This is also equivalent to 60 ml 0.1 normal MnO2, right everybody? Yes. That means, now, that means that amount of MnO2 is equal to normal multiplied with equivalent weight multiplied with volume divided by 1000. Am I right? Yes. So now normal is 0.1. So 1 by 10 multiplied with, what is your equivalent weight going to be? Your equivalent weight will be 55 and O2. 55 plus 32. 87. 87 divided by 87 into 60. 87 divided by 2 MnO2, right? 2 gram sample, yes. So 87 divided by 2, 60 divided by 1000. Calculate this. What do you get? Calculate this. How much do you get? How much are you getting? What is the result? And then you have to find the percentage, isn't it? The percentage of MnO2 in the sample. So how will you find the percentage? Whatever is the result that you get, divided by 2 multiplied with 100, that will give you the answer. But now I think we will just be able, just about to complete the questions and then we will be done. I think another 10 minutes. Another 10 minutes we will be done, bacha. Another 10 minutes we will be done. So quickly calculate and I think you can solve it. Yeah. Whatever is the answer, this will be the percentage. Okay. Calculations you can do, right? Calculations you can do. I'm not doing it. I'm leaving that, everybody. Next question. 0.01 molar KMnO4 solution was added to 20 ml of 0.05 molar Morse salt solution through a burette. Now the initial reading of 50 ml burette is 0 and the volume of KMnO4 solution left in the burette after the end point is dash milliliter. This is going to be very simple, bachos. Everybody knows this, right? This is N1 V1 is equal to N2 V2. Simple. Now N1 is given to you, so 0.01 multiplied with, what do you do here? 5. 5, 5, 5, 5, 5, 5, 5, 5. 1 second. Volume is V1. KMnO4. KMnO4 here should be equal to 5. Yes. 0.01 into 5 into V1 and N2 V2 is 0.05 because that is what is given to you. See, for more salt 0.05 multiplied with 1 and what is V2? V2 is given to you as 20, right? Yes. So from here you can directly solve. V1 is equal to 20 because 5 into 0.01 and 0.05 into 1 is same. So 20 ml is used, right? So that means now volume left. How much volume is left? You have taken 50 ml. So 50 minus 20 is equal to 30 ml. That is what is left for you. Okay. That is what is left for you. Chalo guys. Now Now, let us go to the next question. You know what? Let me go to the last question, and after that, I think I'll leave you because my voice is not able to take it anymore. I'll give you two questions as homework. I'll be sending you the PDF. This is your homework question, and this is your homework question. Okay? These two are your homework question. You will be able to do it because I have done many similar questions just before this. Please do this. And the last one, I'm doing it for you. Dichromate ion is treated with a base. The oxidation number of Cr in the product formed is dichromate ion, so Cr2O7 2 minus, plus treated with a base, right? Treated with a base, so OH minus I can write. Okay, I can write here OH minus. That means what will I be getting? I will be getting here CrO4 2 minus, right? CrO4 2 minus plus H2O. This should be the reaction. Now, what they are asking is, what is the oxidation number of chromium in this case? So here, all I have to do is just calculate it, CrO4 2 minus. So that means X plus 4 into minus 2 is equal to minus 2. So, X, 4 2s are 8 is equal to minus 2 plus 8. That means X is equal to plus 6, and that is your answer. So, oxidation state of chromium here is plus 6. That's the answer, everybody. Now, guys, you all know that you have to join our Telegram channel, because if you join our Telegram channel, you will be getting the DPPs, daily practice paper you get. You will be getting more questions that you can practice before your exam. Try and practice as many questions as possible, regardless of what we are teaching you, what we are not doing, what we are doing, whatever it is, you have to practice problem, and you will be getting certain DPPs here. So please make sure that you are joining the Telegram channel where you will be getting the DPPs. Apart from that, in the description box also we have pasted the link. Just click on that and try and solving the question, because if you solve the question, it will be giving you more confidence, right? You will not be making mistakes where I have done. What did I do? Kappa multiplied with 1000 divided by m. Instead, what did I do? I have taken kappa divided by 1000 multiplied by m, right? So you should not be doing that. That is why you have to practice. Okay, that is why you have to practice. It was such a silly error, right? And that same silly error, I have reproduced it thrice. That those kind of mistakes are something that you have to avoid. See, you know everything. It's not that you do not know. You do know everything. You have been practicing for the last 2 years. You have been aiming for it for the last 2 years. But silly errors, silly mistakes can actually mess it up. So make sure that you keep practicing, keep practicing, keep practicing. Your calculations have to be faster. You cannot use a calculator. So make sure that you do all of this just so that you have more confidence. With this note, thank you so much. Thank you so much for bearing this throat, for bearing my cough, bearing everything. Thank you so much. I'll see you very soon. I think tomorrow I'm going to take it a little bit easy, rest a little, and day after tomorrow I will see you with what? Thermodynamics. Bacha, hydrocarbons will be taught by Pahul sir. Pahul sir will be taking a session of hydrocarbon. Yes. Day after tomorrow I'll be taking thermodynamics. But please do comment and let me know what are the chapters that you require most. I have seen that P block many students are asking, so I think I'll do a P block session of flash series. Apart from that, is there anything, any other chapter that you need me to take you through? Inorganic and physical. Please tell me the inorganic and physical questions that I'll be taking, and your Pahul sir will be taking the organic part. Okay, chalo guys, with this note, tara bye bye, very good night.